Hi, this is Bobby Jo Williams, and this is my Math RBI article evaluation. The article I evaluated was titled Selecting Effective Interventions to Increase Math Computation Fluency via Brief Experimental Analysis. And this study design used the brief experimental analysis, which you just heard in the title, and BEA will be referred to from here on out. That's what we're talking about. It is an empirically supported assessment procedure to determine the success of interventions. It tests the student's response to intervention prior to extended implementation of that intervention. It uses a brief multi-element design to quickly test the effects of multiple intervention components, and it quickly identifies interventions that remain effective when implemented over numerous sessions. The purpose of the study had three particular research questions that the researchers were asking. Will students demonstrate differential responding to math fluency interventions during a BEA of the interventions? Will the student's response to an intervention during the BEA predict students' response to an intervention during an extended analysis? And will interventions identified as most effective during the extended analysis continue to produce the improvements in math computation fluency during an intervention phase in which the most effective intervention is implemented in isolation? The purpose of the study, again, these were the subjects that were studied. There were two actual studies that occurred. In the first study, there were 4 participants, an 11-year-old Caucasian male from a general ed classroom, a 12-year-old Caucasian male from a general ed classroom, a 10-year-old African-American female receiving special education services, and a 12-year-old African-American female from the general education classroom. The second study was conducted with 4 participants, an 8-year-old Caucasian male, 2 7-year-old Caucasian males, and an 8-year-old Caucasian female. All of the participants in the second study have never received any prior math intervention services at school. So why did we do this, or why the researchers did this? Many school-age children with and without disabilities struggle with math. 50% of children in special education have IEP goals in math. NAEP found that only 42% of 4th graders are proficient in math, and a study of 14-year-old general education students revealed that 85% mastered addition, only 81% mastered subtraction, and approximately 50% mastered multiplication and division. I found that crazy. So the dependent variables were different in each of the 2 studies that were conducted. In study 1, CDPM, or correct digits per minute using the standard curriculum-based measures procedures, was used. And in study 2, the total correct digits completed in 2 minutes on the Ames Web grade level math computation probes. So the independent variable in study 1 was part of this BEA that we talked about in the beginning. The procedures were a little long, and some documentation was done throughout. So the first part was the screening. Students had to have performed at the frustration level of performance for math computation fluency. And then a baseline included procedures identical to screening procedures where students completed at least 3 math computation fluency probes, and they did not receive instruction prior to completing the probes. Then they entered what was called the reward condition, where in the reward condition, a unique set of multiplication and division facts was randomly assigned, and the students would be given prizes determined by whether or not they showed certain numbers were correct on each of the probes they were given. Next, it went into the CCC, or the cover, copy, compare, and during this condition, the participants completed multiplication and division problems using the cover, copy, compare method. Then they went into the CTD, or constant time delay, and during this time, randomly selected multiplication and division facts were presented to the students on 4x6 index cards, and they were presented 3 times during each trial in random order. They were directed to read an item, and then the student was to provide the answer if known. Then the experimenter provided the correct answer to the student if necessary. And during the first two trials, the interventionist immediately provided a verbal prompt for the correct answer. But after the first two trials and the third one, there was a 3-second time delay. And then the control was similar to the baseline. There were no instructional components or feedback provided during that time. And now we go into the extended analysis. So the extended analysis was conducted where over several intervention sessions. The extended analysis included rapid alternation of the most and least effective conditions identified. The conditions were implemented in random order, and then participants were removed from the class during the sessions, and all interventions were conducted in an empty classroom free of distractions. These lasted approximately 20 minutes. Then the students were put into the intervention phase, where the intervention identified as the most effective during that extended analysis was implemented in isolation. So the independent variable in study 2 was similar to study 1 with the exception of the extended analysis following the BEA without a withdrawal phase, and there was no control condition in study 2. So for methodology and measurement, researchers specifically measured the change in the dependent variable with the following assessments. In study 1, CDPM was used along with the curriculum-based measures in math. And in study 2, the correct digits completed in 2 minutes on the Ames Web grade level math computation probes was used. As far as reliability and validity, in study 1, independent scorers were graduate students in school psychology and were trained to conduct CBM procedures prior to the study. The agreement during the training sessions had to be above 90% before being allowed to participate. A treatment integrity checklist was developed as well as the control. The treatment integrity was expressed as the percentage of procedural steps completed accurately. Then procedural integrity for all conditions ranged from 94% to 99.29%. So the results. The results of the two studies included the following answers to the research questions that were formulated at the start. So for question number 1, will students demonstrate differential responding to math fluency interventions during a BEA of the intervention? The results were mixed. Only 2 of 8 participants displayed differential responses to interventions during the BEA. Question number 2, will students' response to an intervention during the BEA predict students' response to an intervention during an extended analysis? The results were more favorable. 6 of 8 students showed that the intervention with the greatest rate during the BEA was also the intervention with the greatest rate during the extended analysis. And the last question, will interventions identified as most effective during the extended analysis continue to produce improvements in math computation fluency during an intervention phase in which the most effective intervention is implemented in isolation? The results for that were also favorable. So the discussion parts of our research-based intervention, the present studies provide additional support for the use of BEA to quickly identify interventions that will produce improvements in student performance across numerous sessions. They provide support for Tier 3 intervention procedures when choosing a math intervention program. The authors of these studies compared their results to that of another study which also conducted BEA and found similar results. This suggests that BEA is an effective method for finding math fluency interventions that are able to be generalized over numerous sessions. Some limitations mentioned. Well, there were only 8 students who participated, and generalization of effects from the interventions to classroom performance was not assessed. The studies were conducted utilizing expert consultations, and feasibility of other schools having access to this is questioned. Also, the studies were conducted to research math fluency for basic math operations such as addition, subtraction, multiplication, and division, and it is not known whether it would generalize to more complex math skills. The evaluation of this RBI, what type of preparation would be needed to implement this strategy? I think we'd need training of the instructors giving the intervention so they know what cover copy compare is, and constant time delay. Also, we would need materials gathered for these particular events during the intervention, and also some rewards. What type of training would be needed to implement with fidelity? Teachers implementing the intervention would need to be trained to score the CBM materials and practice agreements until it reached the designated 90%. And also procedural techniques would need to be taught to the interventionists. What would a fair timeline be? I would say about 2 weeks after the initial identification of the students, because there's not really a lot of prep, just the training of the interventionist using the program. And how do you think students would show academic improvement as a result of the implementation? I believe they would improve on grade level assessments and in their daily work, because this was just to provide intervention for math fact fluency. So really, unless there's a specific test used for that in your school, I would think you would be able to see the improvements on their grade level assessments. Would this be a valuable strategy to implement? I feel as though this strategy would be very successful in helping to identify specific fluency interventions for our Tier 3 students. And what would the timeline and cost be to implement this strategy? I believe the only cost would be for the consultation of experts on how to begin implementation and training of teachers. The BEA process itself is really able to be implemented with little cost. And then the reference for this is listed here.